You know, it's one thing to learn about analytics coding, and it's great for your efficiency and for your flexibility as an analyst. But it's a whole nother thing to know how to apply analytical techniques. And that is what we'll talk about in today's video. Hi, I'm Brian Amrine with Value Driven Analytics, and in this video, we'll talk about several data analytics techniques. We'll talk about pulling data and exploring it. Then we'll talk about manipulating data. We'll talk about building interactive dashboards. We'll talk about grouping and aggregating data. And finally, we'll talk about trending data over time. All common techniques that are important to understand as a data analyst. If that sounds good to you, let's head over to our PowerPoint. Let's talk about some common analytics techniques that analysts use. The first thing you do in a project often is to determine what the right tables to use are. Might be that you've worked with them in the past, or you have to ask someone else about what tables, where certain data lives. And it's important to then understand what that table represents and validate that, especially answering the question, what does one row represent in this table? It's important to avoid duplicate issues. Then you might need to manipulate that data in the table that you're in. Determine which columns to select. Maybe you need to create some columns. What rows need to be filtered and what tables need to be brought together in order to get the ultimate table that you'll use for your analysis. Interactive dashboarding is another popular technique that we've talked about as we went through Power BI and Tableau as a couple of dashboarding examples, but that involves importing data into an interactive visualization platform, creating interactive filters, cards, tables, and charts, designing your dashboard, and ultimately publishing it. Another data manipulation technique is aggregating or grouping. SQL does this really well. This involves rolling up totals to compare across the different values of a column, aggregating data together. Trending is a very important thing to do. You don't want to just look at a comparison over an entire time period and not consider how that might be changing over time. So monitoring a certain metric by week, by month, by quarter, by year, and how that is potentially changing over time is extremely important. Performing statistical analysis is a critical skill that especially a data scientist is expected to be able to do. You might conduct a t-test to assess whether there's a statistical significance across two groups. It's one thing to just look at how different two groups are. It's another thing to determine whether that's potentially just due to random chance or actually statistically significant. When it comes to data science models, data scientists need to have that skill. They need to be able to build models that either predict something into the future, maybe which customer is going to buy or which customer has a higher likelihood of buying, or what sales will be for the next 5 months, or prescribe an impact. What is the impact of this variable on this other variable? Data science modeling is a great technique for accomplishing that. And then there's A/B testing. This is the best way to determine the value that a certain treatment or initiative is driving. It involves randomly assigning observations, which could be people or products or geographies, but randomly selecting observations to belong to a test group, which will receive a certain treatment or initiative, and a control group, which will not. And by randomly assigning observations to each group, the only thing that is different across the groups in aggregate is the fact that the test group received a treatment, which means that any differences across the test and control group in the metric you're trying to measure can be ascribed to the treatment itself. And then you can use a statistical analysis like a t-test to determine whether that difference is statistically significant. That's an example of how these different techniques, and this is certainly not all of the techniques an analyst would use, but these are several techniques that can be used in isolation or together to ultimately accomplish an analysis objective. Let's dive into each one of these. Exploring data. Exploring data involves finding and understanding a specific data table. And a data table is simply made up of a set of rows and a set of columns. We have an example over here. This would be a table that is one row per month product combination with the number of sales that occurred for that particular month product combination. It's a set of rows and a set of columns. Simple as that. Now, when you begin an analysis, especially if you're at a new company or you're working on an area that you haven't done much analysis in the past, you may need to go to another analyst or the business intelligence or IT team to ask for access to a table to find out what the table is called, where the information that you're looking for resides, and you may even be able to get a starting SQL query from them, which might have some common filters that should be considered. Perhaps the most popular columns or the key columns that you might want to start selecting. It can give you a great hint of where to start if you can get a SQL query, and of course, ask some clarification questions. Now, it is absolutely critical that you understand for every data table you're using this key question, and that is, what does one row represent in this table? In our table on the right here, you can see that there is one row for every month product combination. Other tables might be one row per product, one row per month, one row per sale, one row per customer, but you need to, one, answer that question, and two, validate that that's the case. And we'll eventually, when we get into SQL, talk about how you can validate what one row represents in that table. But if you can't answer that question, or maybe you have an idea of what one row represents, but that's not actually what one row represents, you can easily run into duplicate issues, and that's where attention to detail can fall apart. Let's talk about data manipulation, and especially data manipulation in SQL, which I highly, highly recommend learning. And we'll have a dedicated session to that. Let's just go over some of the basics of SQL for now. First, there's a select statement. This identifies which columns to include in the resulting data table. We're ultimately writing a SQL query that will run. We saw an example of that in SQL Server Management Studio in the brief SQL section we covered. It starts with a select statement that covers what you want to pull, and in some cases you can even define a new calculation. This is an example where we're taking the sales variable and the existing price variable, multiplying them together to create a new revenue variable. That'll be an extra column in our data set. We use variable and column interchangeably. We need to specify in a SQL query which table the information will come from. In this case, we're starting with one called sales table. And then in the next line, we're actually joining that with another table, and we specify how to join those tables. We want to join the rows in the first table with the rows in the second table where the value within each table's product column matches. This is optional, but in a lot of cases, you'll want to have a where statement that filters the results to a certain requirement. In this case, we're only going to return rows where the product column from the sales table equals apples. We're not going to include those orange rows. And then oftentimes in a SQL query, not always, you'll have an order by statement that tells you how to order the data. Now there are other SQL clauses as well, optional, but this SQL query would run and it would return a data set that has, for all the rows where product equals apples, the month, the price, the sales, and the revenue column. Again, it's absolutely critical to answer the question of, for the tables you're pulling from and the table that you're about to create with the SQL query, what does one row represent? And validate that that's the case. Okay, same data set, but now we've brought it into an interactive dashboard. In particular, we have created a title, we have some slicers on the side that we can essentially use to click and filter down to just apples or just oranges or all of the above. If we select all, we can filter on certain months using this month filter we've created. And we've created a table here that has 3 columns. We could create charts in addition. You can see I've used some conditional formatting bars in the background of sales here. just a way to visualize how sales have been changing by month, by product. There are lots of other ways we could visualize as well. And the idea is that if we use these slicers, it'll filter down this table and any other visualizations that we'd created as well. So we create this after importing the data, perhaps using a SQL query in a platform like Power BI. And after we've created it, we would publish it and make it available via a link to our stakeholders. And now they can interact with it and see the latest data whenever they need to. No manual work involved. Now let's talk about aggregating and grouping, and I don't think there's a better tool to do that than SQL. Here's an example of a SQL query that aggregates sales by product. You can see we're using an aggregation function in SQL. This is sum. You can also use things like count and min and average, but we are summing sales and we're summing them by product. And this is key, we are grouping by product. That allows us to have the following output. This is what we might see in either Power BI or perhaps SQL Server Management Studio, whatever engine we're running our SQL query in. Now we just get 2 rows, 1 per product. And what it's done is it's compressed all the rows for apples, all the rows for oranges, all the rows for each value within the column that you are grouping by. It's all boiled down to 1 row now that in this case is the sum of sales. And it shows us at a high level what the sum of apples and oranges are over this time period. Really neat. Now, before we saw that there were more apple sales than orange sales over our entire time period, January 2022 to the beginning of 2023. But it's also a good idea to check if that difference has always been the case, and that's where trending comes into play. On the right side, we have created a trending chart in Power BI. This could also be created in Excel or even in a SQL query where you're grouping by month, perhaps. We can see in this case it's important to look at the difference over time because even though apples overall during this time period had more sales than oranges, in the last couple of months, and even more so in the latest month, orange sales have been significantly higher than apples. You would miss that if you just looked at the overall comparison by product and you didn't trend it over time. You can also sometimes identify data issues this way. Now, it's also very common to look at the year-over-year change over time, and that's important because in some cases, a trend could be driven by seasonality. So for instance, this spike we see here, we saw the same spike last year. Most metrics, sales or whatnot, have at least some amount of seasonality, and that's where year over year comes in, and looking at not just what's the year over year for this time period, but how has that year over year difference been trending. Now, it's very important to understand and look back and see, well, what's really driving that? Was this driven by, if the year-over-year trend is changing, is this driven by a abnormally low last year, and that's why it's high this year? Or is it an abnormal high this year, and that's what's driving an increase in year-over-year growth? So keep that in mind when you're looking at year-over-year growth, but it is very common to look at year-over-year change over time, by month, by quarter, by week. If you like this video, I hope you'll consider liking it formally. And if you'd like to see more analytics, data science, and leadership training videos, please consider subscribing to the channel. Finally, if you have any questions on what we discussed today, please leave a comment and I'll try to respond to it as soon as possible. Thanks again for watching, and I'll see you in the next video.